Hi everybody, we're back. We're going to look at what we'll call part 2 of lecture 1 in our little econometrics adventure here. And if you recall where we left off, we had created this little flowchart, what we can think of as a roadmap of learning introductory econometrics, right? And this took us from just thinking of a research topic, formalizing it into a theoretical, then a mathematical econometric model. And now we got to fill out the rest. We're going to talk about gathering the data, estimating the model, diagnostic checking, reformulation, going around that little circle, however many times it takes, testing hypotheses, and then wrapping it all up with interpretation of the results. So again, last time we talked about a theoretical model, what we called that data generating process, turning it into essentially a linear equation with our y variable as a function of our x variables, our econometric model. So for the later stages here, obviously we're going to fill in all the details throughout the course. So we just want to kind of outline the basic ideas, get used to the notation, the concepts, etc. So we are here in what we'll call step 3, right? So again, we've got the theoretical model constructed. We've got it into a formalized econometric mathematical model. But now we need to go and get our data. So we need to put some thought into this, right, before we jump into it. So the first question is, where are we going to get the data, right? What are the different sources of data that are available? In no particular order, what we'll call option number 1 is experimental data, right? So generally this is coming from something akin to a randomized control trial, right? Where the researcher has a lot of control over the questions being asked, the data being gathered, the subjects that are generating that data. So a lot of work goes into it up front, but the good news is the data that comes out of it is going to match your theoretical and formalized econometric model really, really well, because you're in control from the ground up. So generally, in an introductory econometrics framework, we're not going to have the time, the expertise, or the resources to generate our own randomized control trial observations, but we are going to see other people's work and maybe look into their data. So that's going to be one option. What's typically going to be a lot easier to get our hands on is observational data, which is exactly what it sounds like. Anytime something happens and somebody writes down what happened in the form of data observations, that's observational data. So it could be anything from, the weekly unemployment reports from the Bureau of Labor Statistics, or the census data that's generated by the government, or the price of a stock at the end of the trading day yesterday that's reported by Yahoo Finance. That's all observational data. Another option is survey data, where again, you're going to have a fair amount of control over the types of observations that are going to be generated. And these days, it's really easy to generate survey observations. We can do something like a Qualtrics survey, a free platform, one of many available online. And for those thinking ahead to constructing a data project, an econometric project, that is going to be an option. Somewhat similar, though, to a lesser extent to the experimental case. You've got a lot of control, got to put a lot of thought into it up front, but if everything goes well, your data should match the question that's being asked pretty well. So, kind of two ways to think about why this is so important, this question of data source. Number 1, obviously, if we're the ones that need to generate the data, we're conducting a research project, we need to know where to go to get that data. The other way to think about it is if you're reading somebody else's work, critiquing their econometric output, the way in which you go about it, the analysis, depends on where the data came from. So we need to kind of ask that question up front, right? So that's issue number one. Once we get the idea of, okay, where the observations, excuse me, are coming from, now we need to know kind of the dimensionality of the data, if you will. Across what dimension are we measuring variability? And there's basically two dimensions that we're going to be concerned with: variation across time and variation across individuals. So a pure time series data set typically has a single entity being measured at multiple points in time, right? And for now, we're just kind of getting used to the notation. So whenever you see that notation little t, that's the index of time periods. So t equal to 1 in period 1, t equal to 2 in period 2, and big T is the sample size, right? So for example, if we're doing kind of a financial analysis, we're tracking, say, the price per share of Apple stock day after day after day. Well, that's a pure time series dimension. Okay. Whereas cross-sectionally, we would be measuring variation across different firms, say, for example, all at one point in time. And here we'll index the observations by I instead of T, right? So when I equal to 1, that would, say, be firm number 1. I equal to 2, firm number 2, etc. So we can generally tell right away if the notation is done correctly. If we see a Y sub T, well, that's our dependent variable Y measured across time, indexed by T. Y sub I, our dependent variable again, but now measured across entities, be it individuals, firms, countries, states, whatever the case may be. So those are the two dimensions. Well, we can measure them both simultaneously. So what we would call a panel data set, a pooled data set, or a longitudinal data set, those are all kind of the best of both worlds. You're simultaneously gathering data across individuals over multiple points in time. So in our little example here, we might be tracking 100 different firms day after day after day over a year. And the idea is exactly the same. We need to think this through from the perspective of a researcher, which dimensionality best fits the question that we're asking, the theoretical construct that we have. And then once we know where the data came from, what dimensionality we're using, that's going to give us an indication of what estimation strategy is going to be most successful and what problems are most likely to arise. So again, that's for later on, but now just recognize this is something that we need to think through. Okay? So, data source, dimensionality, kind of data organization, those are the first two questions. And just if we needed a visual, right? So what our spreadsheet might look like in a time series sense versus a cross-sectional sense, they look more or less the same, right? It's just columns of numbers, but what you need to know is, what is this identifying column represent? So it might be in the form of a date, like we have here. It might be in the form of just a ticker, right? A time trend. So when time equal to 1, our Y variable equals 10.2. Say this is an interest rate. The next period, it's equal to 10.9, etc. So we would need to know, is this variation day by day, year by year, quarter by quarter? You need to know the frequency of that time series. And then with cross-section, the identifying column here, again, now this is going to be representing individuals within the sample. So this might be country number 1, country number 2, whatever the case may be. Again, you've got to know what that data represents. And then when we have both dimensions, well, we're going to need two identifying columns, right? So observation 1 here is firm number 1 on day 1, and this might be their daily return on their stock. Same firm the next day, here's their return there. So we see this grouping by individual and variation over time. Okay? So down here is firm number 2 over the same 3 days, for example. We're probably not going to see a lot of panel or longitudinal data in the introductory level here, but it should make sense that it's going to open up the possibilities, right, in terms of interpreting our results. So we've introduced quite a bit of notation here. So just to quickly review, when we see that little I, that denotes cross-sectional variation, our index of individual entities. The little t, variation across time. Big N, that is the sample size in a cross-sectional data set, the number of cross-sectional observations. Big T, time series sample size, so the number of periods in our sample. And then note in that panel or longitudinal sense where we have both, the total number of observations will be N times T, so the number of entities observed across time. So we'll just be familiarizing ourselves with that notation. Okay, a couple more issues here. Questions that we need to have answered as we're gathering our data and interpreting our analysis. The next question is, what level of aggregation makes the most sense for your particular question being asked? Do we want to look at it at the micro level or the macro level? And it's not always obvious which is going to be better. So when we think of micro level data, as the name implies, it's individual level entities, individual firms, individual households, etc. Whereas macro level indicators would be aggregated or averaged across multiple entities. So when I do kind of analysis of the U.S. banking industry, this is the first question you generally have to address if we want to figure out what's the impact of monetary policy on the economy. We can look at how individual banks behave, or we can look at how the total market behaves, or the total economy. And one isn't necessarily automatically better than the other, but you got to think it through ahead of time. Okay, then one other question we need to know, are we going to look at purely quantitative observations, or could we also include qualitative observations? So quantitative observations, that's what we normally think of as data, right? So these are typically continuous observations representing actual outcomes, right? So the number itself represents a specific outcome, whether it's a number of dollars being spent or dollars being earned or a percentage of the labor force that's unemployed, whatever the case is, the number itself is the outcome. And it varies either by integer or on a continuous basis. But there's going to be a lot of cases where the factors that influence our variable of interest, or maybe the dependent variable of interest itself, can only be captured as a qualitative indicator. And as that name implies, what that means is it contains a specific quality, but might not vary in a continuous fashion. The easiest way to think about qualitative data is that it's an answer to either a true-false question, yes or no, or a multiple choice question. So it's always going to be a coded outcome. So there's always going to be another layer of information that's going to be necessary to interpret it, right? So we might think about marital status influencing, say, your employment. Well, you're married, that's either a yes or a no. It doesn't vary continuously between that or above that or below that, so it might be coded as a 1 and a 0, a binary indicator. Or say a multiple choice type question, if we're looking at modes of transportation, you either drove to work, code that as a 1. You took the bus to work, code that as a 2. You carpooled, code that as a 3, etc. So those are all, you will see them in the data as numerical values, but they are coded qualities, qualitative outcomes. And often those are the most important variables in an analysis. So not to be overlooked. Okay, so to think about an example here, let's go back to the little equation that we had last time where we were thinking about a data generating process and an econometric model predicting economic growth, say as a function of the political environment of an economy, right? Does democracy influence growth? Well, if that's the question we were going to try to address, let's kind of go through the scenario. How are we going to do it? Where are we going to get the data? Is this going to come from a controlled trial, a randomized experiment? Is it going to be observational, or is it going to be survey data? Almost every case, the ideal scenario would be a controlled trial, right? Because we have control, right, over where that data comes from. But at the macro level, right, imagine what this would entail, right? We would have to say, okay, we've got 190 countries in the world. We're going to take half of them and make them dictatorships. The other half we're going to make full democracies. And then we'll see how that affects growth. Well, you'd have to get a lot of people on board to engage in that experiment. So that's obviously not going to be possible. And likewise, survey data probably doesn't make a lot of sense. You're not going to call up people and say, hey, do you live in a democracy? Yes or no. So it's probably going to be an observational data set, right? That's the most likely in this case. Then once we have that, what about the dimensionality, right? Is it going to make more sense to see how growth is affected by democracy over time within a single economy or across different entities? Well, in this case, our key X variable, democracy, doesn't tend to change very often, right? Again, the political science in this is very interesting. But an economy, once an economy is established as working in a democratic political environment, it tends to stay that way until it discontinuously turns into a dictatorship. I'm not trying to be political here, don't get me started. So it's probably going to make more sense to think about this in a cross-sectional sense. So let's look at all the economies in the world. Let's rank them by democracy all the way down to pure dictatorship. And that would be the X variable. And then our variation in our dependent variable, some form of poverty or growth measure, would also be varying across countries. And that's kind of the next question. What about the level of aggregation? Would it make more sense to look at poverty and growth at the micro level or at the macro level? You could do it either way. If we were going to do this at the macro level, right, we'd probably look at just GDP growth rates country by country by country. So our data set would be organized at the macro level cross-sectionally. And then quantitative versus qualitative, you might have something like at the micro level, we might measure growth as whether the household is below the poverty line or not. So a 0-1 case. I don't know why I didn't think about the democracy variable, because we can think of that as kind of an either-or situation. It's a 1, coded as a 1 if the economy is democratic, and a 0 if it's not. I know there are shades of gray in between, but that might be a good candidate for a qualitative variable. Okay. So, again, just think of that as a simple exercise, but every time we're thinking about or examining an econometric model or econometric results, think critically about the nature of the data. Okay, so now these last ones we'll go through real quick because this is where we're going to spend the next couple weeks filling in a lot of these gaps. When we talk about estimation, again, what we're trying to accomplish here is finding the optimal estimated values of all of those parameters within our econometric model, the B0 intercept, the B1 ... associated with each of our X variables. So this is going to lead us to the mathematics of ordinary least squares estimation. We'll get to that next. But think of that as the next step. So we've already done a ton of work and we haven't actually really done any analysis yet, right? We've just thought through the theory, thought through the data, gathered the data, then we do the estimation. And again, for the notational aspect of it, when we see that B0, B1, B2, etc., That's what we're trying to get at, right? Those are the true population unknown values. The estimation, right, is going to come from a specific sample. So what we're going to actually see is what we'll call the B0 hat and the B1 hat. So this is the given sample estimates of the true underlying parameters. So we'll never know what those true values are. When you're actually given a number, calculated a value from a sample, that is the hat, right? That's the estimated value of the true unknown. That's what Stata ultimately is going to give to us, right? Based on our data. So once we've got that, again, now we've got to do all of our testing and checking. So this is going to be about 4 chapters worth of material that we're heading into, our diagnostic tests. Does your data and estimation equation conform to the theoretical model that delivers valid results? That's going to make a lot more sense in a couple weeks. We're going to have a nice little checklist of what to look for, what issues are likely to come up. But before we get to the point of saying, okay, now I know the answer to my question, there's a lot more work that we're going to need to be doing, right? Make sure that we have some confidence in those results. And we're often, going to go through multiple iterations of our estimation. So correcting those diagnostic issues that came up, changing our specifications. Some variables aren't doing any work for us. We can pull those X variables out of our model. We can change the functional form. It doesn't have to be a simple linearization. We can add new variables in there. And we can, in fact, entirely change our estimation strategy. All things that we will get into in excruciating detail in the coming weeks. Okay. Then hypothesis testing. Again, this a necessary step in order for us to extract information. We're talking about at what level of confidence can we say that our estimated values are different from 0, right? If those coefficients are 0, what that tells us is there's no relationship between X and Y. So how much confidence do we have in a positive relationship or a negative relationship between our X variables and our dependent variable? Lots of things that are going to go into that mechanically and theoretically. And that's our step number 7. And then finally, that takes us to step number 8, which again is where you really earn your money, as you take all of the statistical output and use it to tell a story. So that's our interpretation, the narrative context that we're going to place on this, which again, in that little roadmap, links all the way back to step number 1. So what did we learn about the theory that we started with through our data analysis process? So a narrative, a context that we're adding. So real quick, let's give this a shot in terms of thinking through some of these issues from an actual research article. So we'll take a look at the abstract, the little summary of a research project, and we'll try to answer some of our basic questions. What is the Y variable? What is the X variable that they're focused on? What is the data generation process? What is the econometric model that they're operating with? And then talk about the type of data, and that goes into data source, dimensionality, aggregation, qualitative versus quantitative. And then what is our interpretation of the sign? Is the coefficient positive or negative? They're predicting a positive relationship or a negative relationship. So this is a little bit old now, from 2016, the American Economic Review, kind of the gold standard for published economic research. The title of the article, Poverty and Economic Decision-Making, Evidence from Changes in Financial Resources at Payday. Maybe not a riveting title, but good stuff nonetheless. So let's go ahead and see what they have to say in their abstract here. So when you are thinking about what type of research you want to engage in, you're going to read a lot of abstracts. Not so many complete papers, but a lot of abstracts, a lot of introductions, a lot of conclusions. And with a little bit of practice, after the first sentence or two of an abstract, you should be able to picture what the econometric model, what the equation is that they're estimating, be able to picture what their data set looks like. So let's see how we do here. So we study the effect of financial resources on decision making. That's a dead giveaway right there in terms of our first question, right? We study the effect of X on Y, right? So the effect of, in this case, financial resources, that's their explanatory variable. And how does that impact the left-hand side of their equation, the dependent variable, in this case, some measure of decision making? Moving on, low-income U.S. households are randomly assigned to receive an online survey before or after payday. So that random assignment, that tells us about the nature of their data. Again, here, very likely from a randomized control trial, right? So an experimental source for their data. So the authors are in control of who's in which group and what they're experiencing, right? And then the survey ... collects measures of cognitive function and administers risk and intertemporal choice tasks. So again, it's survey data from the context of a random experiment. Moving on, the study design generates variation in cash, checking, and savings balances and expenditures before payday. Participants behave as if they are more present biased when making intertemporal choices about monetary rewards, but not when making intertemporal choices about non-monetary real effort tasks. So the idea is they split their sample into two. Everybody gets a survey to fill out, and basically they're taking a test, right? Cognitive and your views on intertemporal choice, but half the people take it without money in their pocket before payday. The other half take it with money in their pocket after payday. How does that affect how you view the world? So the people without the money in their pocket are kind of more present based. They're more concerned about issues right now, less willing to save, less willing to put off benefits, etc. So that's pretty cool. That makes a lot of sense. So let's kind of break that down. What is the Y variable? Well, that's some measure of decision making or a measure of present bias. What is the key X variable? And there's probably a lot of variables that they controlled for, but the one treatment effect that they're looking for is, do you have money in your pocket or not? Are you before the payday or after? What would the model look like? Well, here's your Y, here's your key X variable, call it X1, and then all of your other variables that you'd control for. So picturing the equation, it's going to look something like that, and all of their analysis comes down to, what can we say about that coefficient, that B1? What do we get for an estimated B1 hat? All right. So in order to do the analysis, what was the kind of construction of the data set? Well, it's most likely cross-sectional in nature, right? So there's definitely variation across individuals. They didn't indicate that they collected data more than once, right? So I don't think it was a repeated set of tests, which would have implied a panel or a longitudinal structure. So it's cross-sectional. It's also qualitative, partially, right? It's a yes or no question. Do you have money in your pocket or no? Are you before payday or after? So that's going to be a coded binary response variable. You could do it either way, but I'm imagining they would say it's equal to 1 if you are before the payday. So when this goes up, that's going from 0 to 1. So you don't have money in your pocket. And we have random assignment to response groups, right, that we got out of the abstract. That implies both a survey structure and an experimental design. And then we would think, right, when that variable goes up, meaning you are before payday, you become more present biased. So that would indicate a coefficient is positive. It's a positive correlation between the two. So a great exercise to get comfortable with. Opening up, heck, just go, well, okay, you can't really go to the library right now. Go online, search up abstracts from the latest issues of the American Economic Review, and be able to read through it and make some sense out of kind of these 4 issues. The X and the Y, what's the model look like, what's the data type, and what are they saying about that relationship with the key coefficient in mind.